Hey guys, welcome to the day 2 of the tutorial modeling a tree in speed tree and importing it into UDK. So in this tutorial we'll be seeing on how to export a tree into a UDK recognizable format and then populating our terrain with some good speed trees. Uh, Before exporting the tree into UDK, one important thing you have to keep in mind is the level of detail. I've already told you what the level of detail is, but in case you didn't get it, level of detail is the amount of detail that gets actually drawn into the screen. That is, when you are closer to a model, the entire model is loaded into memory and rendered, but as you go farther away, the number of polygons in the model is stepped down by some 50% or such, and then rendered. So this saves more of a rendering performance and gives more time to other parts of the game like physics and artificial intelligence. So that's what level of detail is primarily is. So if you want to see what level of detail looks like in the viewport, just click on anywhere inside the viewport or select the tree node and just click enable level of detail, and immediately you get a bar over here that says low to high. uh, Normally high means the highest level of detail and low means the lowest level of detail. So at the highest level of detail the tree will look like this, but as you go farther away from the tree you can see that as you bring it down you don't see much of a difference. It's just the same tree. You don't see that the polygon number of reduced, but actually at the highest level of detail you can see that there are 6600 polygons, but as you go down it has been reduced to 1300 polygons. So this gives more rendering efficiency into the game. But at closer look you can see that the tree number of leaves is reduced, and other stuff takes place, and the size of the leaves are increased so that it compensates the number of removed leaves. So let's what the level of detail primarily is, and let's go ahead and check out some of the settings that we have in level of detail. Manual means you get this bar that controls the level of detail, but use near and far is whether you are close enough to the scene, or as you go away the level of detail comes into place, so that you don't see any difference over here. You can see that the tree remains fairly constant as you go away from the scene, but as you cross this limit over here you can see that a yellow triangle appears on the screen. That's because at this distance you're not going to get any 3D effect from this tree. So what the viewport generally does, it offloads the entire tree and loads a single image plane or a single plane that consists of less number of vertices, and it just has an texture that has the overall appearance of the tree. So this saves much of the rendering speed as you are far away from the tree, and as you get closer the entire tree is loaded. That's the basic of LOD, and the count is the number of different levels of LOD that you get. 5 means 5 counts of LODs, as you can see over here. 10 means 10 counts of LODs, but normally 3 to 5 is optimal value, so let's set that to 3. And the near setting, well, the near setting is like they are valued as 100, 300, 500, etc. So near setting set to 100 means that if you are less than 100 meters from the tree, then you can see over here we are at 96 meters, so the entire tree is loaded. But as you go farther at 106 meters the second LOD is loaded, and as you get farther at 200 meters the third LOD is loaded, and as you go farther, that is at 300 meters, the next LOD is loaded, and at 400 meters, as you can see over here, the billboard is loaded. That is the two-dimensional plane that is used instead of the entire tree model is loaded, and that's kept in memory instead of keeping the entire tree. So that's the entire concept of level of detail. The default values will do much good, and leaf collision, obviously it helps to decrease the number of trees. So if it's disabled, all the trees will be closer to each other and you won't get much of a spread factor. But enabled, it spreads out the leaves a bit much like that. So optimal value is from 0 to 1. Let's select that to 1. And spread and cull means uh, the leaves that are inside the cull tolerance field of another leaf gets deleted. So that's what cull means. So 0 means no deletion, that is where's that setting? Yeah, 0 means no deletion and 1 means a bit higher amount of deletion. 2 increases the deletion, like that. So any leaf that is 2 units apart from this leaf gets deleted. That's what cull tolerance means. So optimal value is 1. And degradation, it's only for the viewport. So now we have tackled a level of detail. Let's go ahead and uh, adjust some of the properties that come into level of detail. So let's select the leaves and come down, and here you can see the leaf level of detail. The size scalar, so here you can see that this is the highest level of detail and this is the lowest level of detail. So at highest level of detail the leaves are bigger, and as the level of detail goes down, the leaves are made smaller. That's the entire concept over here. So let's leave that at default values. And this keep denotes how much amount of leaves are kept from the highest level of detail to the lowest level of detail, and generally 0.25 is a good value, and others are pretty good. So let's now go ahead and save this tree. Let's save it as pine.spm, and let's now start UDK. So we are into UDK now. Now to import this tree into UDK, just go to browser, content browser, and select import, and go to documents, and you can see that the tree model is not over here. That's because UDK only supports SRT format, SpeedTree SRT format, but the model that we have currently loaded or saved from SpeedTree is a SPM format. So we got to convert this to SRT format. So for doing this, there is a nice tool in UDK that comes along with SpeedTree called the SpeedTree compiler. So let's now go ahead and open SpeedTree compiler. So we are now into SpeedTree compiler. As soon as you start the SpeedTree compiler, you get a window like this. Let's select add tree, and let's select the tree that we want to import, that is pine.spm, and click next. And here you get some various settings over here. One of the settings is merge billboards into texture atlas. That is, the billboards are merged into the textures for the bark and the leaves. So that's what this option means. So let's check that. We want to merge the billboards into the texture atlas to reduce the number of textures being loaded into memory. And this overhead billboard means that when you are creating some games that have some jet planes into it, you're going to fly above the tree. So these billboards are not going to be visible from above the tree because they are just vertical billboards. So create overhead billboards creates horizontal billboards for the tree. So that's just a setting that you have to check when you're creating games with planes. Other than that, you don't need to check this. So with that selected, let's select the output directory as pine tree, and select finish and compile, and just give it some time to render the images. And if we open the output folder, we can see that these are the files that we got. So let's close it, and Let's open UDK now. So okay, once in UDK, just click import and select all the trees and texture maps and click open, and just select OK to all and give it some time to import. And once in UDK, just load up the content browser and click import and select all the textures and the speed tree model and click open. Name this as pine tree and click OK to all, and just give it some time to import all the models and the textures. It'll take a bit longer, so let's wait until it's fully loaded. And there we have all our textures and the model over here. So once you double click the model, you can see that no material has been applied to that. So let's right click and select a new material and name this as bark. Click enter, and let's drag the pine bark over here and pine normal into the scene. Connect the diffuse channels and the normal maps and just save it. And next, add another material, call that as pine needles, and bring in the texture map or the diffuse map, the normal map and the specular map inside the scene, and connect the corresponding attributes. Connect the normal map and the specular map. And also one other thing you want to do is connect the alpha of the diffuse channel to the opacity mask, so that the transparent areas gets blocked out. And one other thing you want to make sure is just select the blend mode to blend masked, so that on the transparent regions gets blocked out. And let's save it. And that's it. And one more thing that I would like to tell to you is that the leaves would look different from that you see, because I've gone ahead and added two leaves or two set of leaf node into a speed tree model, so that we have two leaf textures over here. Well, all you have to do is just add another set of leaf to the level 2 branches, and that's it. You get two different leaves. I just did this because I would get some amount of randomness from the leaves. That's it. So now let's select the speed tree model and select the bark material and click assign, and just give it a minute to load, and do the same for the branch 2 material. And now select the pine needles and assign it to the leaf card material, and just give it some time to load. And now apply the same for the billboard material, because you can see that this texture also contains the 6 different billboards of the trees. So just assign the same and just close it. And now you can bring the tree into the scene, and you can go ahead and scale it to see how the tree has come. So it's pretty nice, as you can see. And okay, so one thing what you have to do is you have to populate the trees inside UDK. So let's first see on how to populate static meshes, and then later on we'll see on how to populate speed tree meshes. So let's delete the speed tree, and let's create a new terrain. Let's select 128 128 for the X and Y patches, and just click finish, and give a minute for the texture or the terrain to load, and there I can see the terrain. I don't know why this is acting like this. Okay, and just go up close. Well, in some of your computers the terrain wouldn't appear. It will be hidden from the view when you create the terrain. So all you need to do is press the T button to toggle the terrain, and you get the terrain. That's it. So now let's delete this plane over here, and let's select the terrain, and move that just a bit like that. And now let's okay, let's go into the terrain editing mode, and let's create a new deco layer, and name that as static mesh or static trees. And let's now load up the content browser and type trees over here, and in the U in trees node you can see that you have got a sample tree over here. Just select that and select add selected decoration, and you get the decoration over here. Let's go to the actor properties, and you can see that the static mesh has been loaded as the deco layer, but when you try painting it by holding down control, before that let's increase the strength to 100 and radius to something like that, and when you try painting the terrain with control key, all you see is just the terrain being edited. Well, that's because by default in some of your systems the min and max scale and densities are set to 0. So let's select them and set them to some sensible values like 1 and 3, and now try painting them, and you can see that we get some nice static meshes over here that are populated as trees. And well, it's the same workflow for adding speed trees to your model. So let's go ahead and delete this deco layer and create a new deco layer and call that speed trees, and just give it a minute to load. Oh shit, I don't know what happened. So let me go ahead and restart UDK. So I've gone ahead and restored the scene. So let's now try adding a speed tree deco layer. Let's create new deco layer and name that as speed tree, and let's go into the content browser and select the speed tree over here, and select add selected decoration, and you can see that nothing happens because by default UDK is not set to accept speed tree as decoration layer. So a workaround for this is just select the terrain and go into the actor properties, and inside the terrain tab you can see that there is an attribute for deco layer, and it has got a deco layer, and there are currently no decorations in it. So let's click on add, and when you expand this you can see that there is a factory setting over here, and it has two values: static mesh component factory and speed tree component factory. By default static mesh component factory is selected, so you can't load in any speed tree materials or meshes into UDK by default. So all you have to do is just select speed tree component factory, and just go into the speed tree component over here, and here you have the speed tree attribute. Just apply the speed tree pine into this, and let's also increase the minimum and maximum scale to 10 and 15, and let's set the density to 5, set the random seed to 6, and now let's hold on to control and try painting the trees, and you can see that we are getting some nice speed trees over here. Let's go farther away, and oh, I'm sorry, just select the speed tree and just paint the entire level with the speed tree meshes like that. And if you want to make this a bit more denser, all you have to do is increase the density to 10, and you can see that we get more denser trees, or denser positioning of the trees. Let's keep that to the default value, or the normal value of 5, and you can see over here that each tree is being modeled different. That is, this tree is shorter, this tree is heighter, as such. And okay, let's just go to the actor properties, or I'm sorry, let's just go to the actor class and add a vehicle over here so that we can navigate the scene. Let's add a scorpion, and a manta like that, and let's select play level from here. Just give it a minute to load. And so you can see that the level has been loaded, and that's an awful lot of sound. So let's try navigating our scene, and you can see that we are getting some nice collision primitives over here. Well, by default, when you drive a car through the speed tree, in the example that I have told you, your car will be directly passing into the speed tree instead of colliding with them like this. That's because the model doesn't have any collision primitives associated with it. So to associate collision primitives with the model, all you have to do is just go into the speed tree modeler. So you can see that here we have imported all the trees into the game, and let's go inside the car, and let's try navigating the scene, and you can see that the trees are swaying realistically in the wind. Well, that's just a light bit of swaying, but it gives some bit more of a realism than static trees. And one other thing I want to tell you is that if you go ahead and try colliding your car with the tree, you can see that well, no collision occurs. The car just passes through the trees as if there were no trees over there. Well, that's just because your trees don't have any collision primitives associated with them, and thus they are not colliding with the real world. So to do that, all you need to do is just start up the speed tree editor or modeler, and just open the tree. I'm sorry, pine1.spm, and you can see over here that the tree has been loaded, and all you need to do is just go to tools and click generate collision primitives. These will generate the collision attributes for the trees. The branch capsules tells the number of capsules or collision primitives that has to be generated for the branch, so it's set to 1 capsule, and the leaf spheres is the number of collision primitives that has to be generated for these leaves over here, and it's set to 4, and the encompass percent is the accuracy with which the collision primitives are generated. Well, the default values will do much good to you. Just click OK, and you can see that you get some nice collision primitives going on over here. If you don't like this collision, then always you can just select them and move them individually, and just accurately position them and save the scene. And as I've told you, you can see over here that I have generated two set of leaves to give some randomness. Both are connected to the level 2 branches of the speed tree. This gives some realistic looking trees without some repeating leaves. That's the whole process in it, and I've gone ahead and created two materials for the leaves to give it some randomness, and just save it and ignore this warning, and compile the speed tree using the same method in the speed tree compiler, and import it inside the speed UDK using the same workflow that I have taught you. Okay, I've gone ahead and compiled the tree, and now let's just delete this speed tree model over here, and just click on import and bring in the new pine tree inside, and double click it, assign the bark materials, and assign the leaf and billboard materials, and select the speed tree, go into the actor properties, and it's been selected by default. And now let's select play level from here, and just give it a minute to load. And now if you see, you can see that they're getting some nice collisions over there, and your car also collides with the trees. That's the basic behind collision primitives. In this tutorial you have seen how to create and import some good looking speed trees into UDK. You have seen how to use the speed tree modeler, and use the speed tree compiler, and also import the objects into speed tree, and use another workflow for importing the objects, or using the speed tree meshes into UDK. That's it for the tutorial over here. Hope you had a good time throughout the tutorial, and uh, thank you guys for patiently listening to my tutorial. Hope to see you soon, and again, this is Madan from CG Tudes Plus.